So let us see how can you say whether a function having derivatives or not. Means every function, last section we studied what is a chain rule and first principle. Now today we will discuss whether all the functions having derivative or not. What is the condition that are required for a function having derivative. Now there are two methods of finding derivative we studied. One is first principle and the second is chain rule. Method of finding the derivative of a function is called differentiation. Differentiation actually means it's a method. One is a first principle method and the second is chain rule. Two methods are there. The method of finding derivative is called differentiation. Now, whether all the functions having derivative or not, for that we need to know what is continuity. Continuity means, in simple language, if we can draw the graph of any function without any break, then such functions are called continuous function. For example, sin x, we know how to draw the graph. There is no break anywhere. Similarly, cos x. So sin x and cos x are continuous functions. But tan x is not a continuous function because the graph is not continuous. At x is equal to 90 degree, x is equal to 90 degree, tan 90 not defined. So there is a break. Similarly, cot x, all the remaining trigonometric functions other than sin x and cos x are not continuous functions. They all having breaks. All the polynomial functions are continuous function. E raised to x is a continuous function. So how can you check without drawing the graph a function is continuous or not? That method is written here. So a function f of x is continuous at a point. You can check the continuity at a point only. Only when limit extends to a f of x and f of a are same. Limit extends to a f of x. Last section we studied. And f of a are same. One of the example you see, one of the example is written here. F of x is equal to this one. This is used in somewhere else, but you can see it's a continuous function. Here anywhere if you are drawing the graph, no break will be there. Only the break may happen this repeating point. So if we put the 0 here, the answer is here also 0, here also 0. This is a continuous function. And here also you may see here there are three definitions. One is repeating two places. So when one I am keeping here, it is one is coming, and when I am keeping here also one is coming. So this function means at x is equal to 1, this function is continuous. But when I am putting x is equal to 2, what happened? 2 into 4, that is 8 minus 2, that is coming 6. But when you are putting here, here also it is coming 6, so it is also continuous. So we may see when I am putting here x is equal to 2, here it is coming 6, here also coming 6. So this graph is also continuous everywhere. Instead of minus 4 plus 4 is there, then that is not continuous. So continuity very easy you can check. Only the problem is arising this repeating point. So these functions are continuous function. Now this is also a continuous function. You see 0 is the only problem coming. 0 here also 0 is coming, here also 0 is coming. So modulus x is a continuous function. So that is written f of x is continuous at x is equal to a if and only f of a means suppose I want to check 0, f of 0 you check it, f of 0 is coming 0, left hand limit, right hand limit, all will come 0, so it is continuous. So f of here also, in this function, if I am putting 1 directly here, then also left hand and right hand limit, they are also same. If 2 you are putting directly here, then also left hand limit, right hand limit, limit and f of a are same. So that all are continuous function. Now secondly, only continuous functions having derivative. So first important rule to make a function continuous is differentiable is it must be continuous. That is compulsory. Continuity is compulsory. Without continuity, we can say it is differentiable. For example, greatest linear function you see is not a continuous function at any of the integers. Greatest linear function is not continuous. Its graph also we are drawing, break is there always. So it is not differentiable at any of the integers. So greatest linear function is not continuous, so not differentiable. If we can say the function is not continuous, so it is not a differentiable. No need to go ahead. Now the third point, that is another important thing. Continuity is necessary but not sufficient to make a function differentiable. Continuity is compulsory, but that is not enough to make a function differentiable. Continuity is required. If not continuous, 100% not differentiable. All differentiable functions are continuous, but all continuous functions are not differentiable. Now, what is the additional thing required is written in the next section. Let us see what is that. Now, you see here already greatest integer function I told you. Now, let's see f of x equal to modulus function is continuous but not differentiable at x is equal to 0. So, already I told you how it is continuous. Very well, no break is there. If the graph you are drawing, no break is there. But you see, if I am differentiating at 0 both of the places, if I am differentiating here, the answer is -1. That is what is called the left hand derivative. Less than what, that is left hand derivative. Right hand part, if you are differentiating by chain rule or formula, RHD is 1. RHD is 1. Both are not same. So, a continuous function is differentiable only when left hand derivative and right hand derivative at a point must be same. So here left hand derivative -1, right hand derivative +1. So we can say modulus x is a continuous function but not a differentiable at x is equal to 0. All other places it is differentiable but not differentiable at x is equal to 0. Now, next point, a continuous function f of x is differentiable at x is equal to a. If you want to say function is continuous, then it is differentiable at x is equal to a only when left hand derivative and right hand derivative are equal. There is a formula to find out left hand derivative. Usually we are not using this formula directly, we are differentiating by chain rule. Okay, so left hand derivative formula is first principle formula itself. I want to check x is equal to a. Actually, first principle formula was f of x plus h minus f of x plus a minus x plus h minus f of x upon h we studied. So same here, but here I will put x as a here. So limit h tends to 0 minus this formula used, and RHD is equal to h tends to 0 plus this formula used. Both must be same, then only function is differentiable. Now one question is there, f of x is equal to x modulus x. I am removing this modulus x by the definition of modulus x. You will get x into minus x, that is minus x square when x less than 0 and plus x square when greater or equal to 0. So modulus x definition is already written here. So minus x into x, so minus x square plus x into x, x square, that is same result is written. Now if I am finding f dash x at x is equal to -1, -1 is a not repeating number here, -1 is coming here only, so you differentiate because neighborhood or -1 are coming only in this place, so no need to check LHD and R3, so directly differentiate and put x is equal to -1. -2x minus 2x as x is equal to -1, so -2 into -1, 2. Similarly, f dash x at x is equal to 1. 1 is coming here only, not repeating. So differentiate 2x, 2 into 1, that is equal to 2. But if I want to check at x is equal to 0, which is a repeating number, so LHD RH is required. LHD minus 2x, so minus 2 into 0 at x is equal to 0, we want to check, that also 0. RHD 2x, 2 into 0, that is also 0. LHD and RHD are same, so we can say f of x is differentiable everywhere. So at 0 also differentiable. What is the derivative at 0 is 0 itself. So everywhere it is differentiable. At x equal to minus 1, derivative is 2. At x is equal to 1, derivative is 2. At x equal to 0, derivative is 0. So all anywhere differentiable. Now we see this function. As I told you, it's already continuous. So f dash x, if here I am differentiating, 3 is coming. At 1 is a repeating number. So at x is equal to 1, I want to check. So left hand derivative, here coming 3. Here also come 3, 4x minus 1, differentiating 4x minus 1, put x is equal to 1. There also you will get 3, LHD and RHD are same. So f dash x at x is equal to 1 means f dash 1 is 3, derivative at 1 is 3. But at x is equal to 2, let's see, 2 is also repeating. Here I am repeating, here it is coming LHD 7, 4x minus 1, 7, 4 into 2 minus 1, 7. But RHD is coming as 5. LHD and RHD are not same. Here LHD and RHD were same. Here LHD and RHD are not same. So f dash 2 not exist. So let us see some other examples. F of x equal to modulus x minus 1 plus modulus x plus 2 is not differentiable at x is equal to 1 and minus 2. So I want to remove this modulus. It is very simple. You make a number line and find out the values of x when each of this modulus is coming 0. Modulus x minus 1 can be 0 when only when x is equal to 1, and modulus x plus 2 equal to 0 only when x is equal to minus 2. One thing you may observe that wherever the modulus value, for whatever the values of x, the modulus value is coming 0, their all the functions are not differentiable. How it is, let's see. Now I want to remove this modulus. It's very simple to remove. So I have drawn the number line here and I took a point less than minus 2. Here it is given less than or equal to minus 2. Better you put a number before minus 2. Suppose I am putting minus 3. Inside this modulus, what is happening, you see. If this complete inside the modulus will come negative, so its negative is written. So minus x plus 1. Now inside this modulus is also minus 3 plus 2, that is also negative. So inside this modulus also everything is negative, that is why minus x minus 2 simplify minus 2x minus 1. For any number less than or equal to minus 2, this complete function is minus 2x minus 1. Now take a number between minus 2 and 1. What is written there? Minus 2 less than x less than 1. Suppose I am taking a number 0 in between. So 0, if I am putting here, it will come negative. That is why negative of this number is written. And here it is coming positive. So that positive is written like that. So simplifying it will come 3. Any number from minus 2 to 1. Similarly, number more than 1. Suppose I am taking 2. This also will be positive, this also will be positive. So like that it is written, simplifying 2x plus 1 for any number greater or equal to 1. You may see that this complete function is continuous but not differentiable at 1 and minus 2. So because minus 2, if I am to minus 2, f dash x at to minus 2. Left hand derivative here I am checking minus 2 will come, but right hand derivative will come 0. Its derivative is minus 2, its derivative is 0. So LHD not equal to RHD, not differentiable at x equal to minus 2. Similarly, f dash x at 1. Here is 1. If I am differentiating left hand derivative 0, but right hand derivative 2, LHD not equal to RHD, therefore f of x is not differentiable at x is equal to 1 as well as 2. If any function inside the modulus is becoming 0 for the value, for that all values the function will not be differentiable. But at x equal to 0 it is differentiable. 0 is not repeating, only one place 0 is coming, so only you differentiate. Neighborhood of 0 are coming only inside x, so derivative at 0 is 0. Any other number also like that. No LHD RHD required. Now, what is an explicit function? In left hand side y and right hand side only terms of x, such functions are called explicit function. The importance of explicit function is you can find out the derivative directly, dy by dx is equal to f dash x. Or Derivative of y with respect to x is called dy by dx. Derivative of x with respect to x is 1, but derivative of y with respect to x is dy by dx. Now, implicit function. If you are not able to write y is equal to f of x, that means y not equal to f of x. You cannot be able to write y is equal to f of x. Such functions are called explicit. It is most possible to write y is equal to f of x form. Such cases, each of the terms you differentiate, x square derivative is 2x, y square derivative 2y into chain rule applying, 2y into y derivative dy by dx, here 2x into x derivative 1, here 2y into y derivative dy by dx, x derivative 1, y derivative dy by dx minus 4 derivative 0, simplifying you will get dy by dx. Collect dy by dx from different places, you can find out dy by dx. That is a implicit function. Now there are a few more derivatives left for inverse functions. So sin inverse x derivative dy by dx of sin inverse x is 1 upon root of 1 minus x square. You keep it in mind, derivatives are defined only for the domain. So here the domain is minus 1 to 1. X must be minus 1 to 1. Similarly, cos inverse x derivative is, you put a negative here, minus 1 upon root of 1 minus x square. Means an inverse function and a complementary inverse function having derivative with the negative symbols. Sin inverse 1 upon root of 1 minus x square, so cos inverse is negative. Similarly, tan inverse x 1 upon 1 plus x square, so cot inverse x is negative. Sec inverse x is 1 upon x into root of x square minus 1, and cosec inverse x is negative. That also you have to learn with the formulas. Last section or in 11th standard you studied 10 plus 6, 16 formulas are there. Now, one or two examples are there. If y is equal to sin inverse of e raised to 2x, this is an explicit function. So we can find out dy by dx directly by chain rule. 1 upon root of chain rule applying sin inverse derivative written here. 1 upon root of 1 minus this x square. So here instead of x e raised to 2x is written, so 1 upon root of 1 minus e raised to 2x square into, now e raised to 2x derivative is e raised to 2x into 2x derivative is 2, chain rule which we studied in the last section. Similarly, this is also implicit function, explicit function, so dy by dx directly it is possible to find out. E raised to derivative is e raised to itself into tan inverse derivative is 1 upon 1 plus x square, this x square. Here x is root x, so root x square into root x derivative is 1 upon 2 root x. It can be further simplified and not simplified, you can further simplify it. So let us see another example. Differentiate log x to the base 10 with respect to x. Here base is 10, so we cannot directly differentiate. First we change the base log x upon log 10. Now the base is e. Here log 10 is a constant which is not equal to 1 because the base is e. So dy by dx is equal to 1 by log 10 constant into 1 by x. That's a derivative. Now what is a parametric function? If x and y are in dy by dx, both x and y are variables. If x and y are defined with a third variable, then that third variable is called a parameter. Third variable is called a parameter. Here I took theta as a parameter, so y is equal to a function in theta and x is another function in theta, where theta is a parameter. Parameter means variable itself. Okay. So dy by dx is equal to differentiate y with respect to theta divided by differentiate x with respect to theta. So we will get dy by dx. One example. If x is equal to sin inverse 3t minus 4t cube and y is equal to cos inverse 1 minus t square. If we are putting t is equal to sin theta, so it will form a sin inverse sin 3 theta. It will form 3 sin theta minus 4 sin 2 theta. So theta I am putting, that is sin inverse sin 3 theta is 3 theta. So that is 3 into sin inverse t, not x. It is a sin inverse t. And y is equal to cos inverse, here 1 minus sin square theta is cos theta, so cos inverse cos theta is theta, that equal to sin inverse x. Now we are differentiating dy by dx, y derivative is 1 upon root of 1 minus x square y derivative divided by 1 minus x square, not this also t, so 1 minus t square divided by t square, and the result is coming 1 by 3. Similarly, another question is this and this are given in terms of t, so parametric function, so dy by dx is same as derivative of y with respect to t d upon derivative of x with respect to t. Now y derivative is written in the numerator, e raised to is e raised to itself, chain rule, cos 2t sin 2t derivative is cos 2t, and 2t derivative is 2 divided by x derivative with respect to t, e raised to itself, cos derivative minus and into 2 to derivative 2. This is equal to e raised to sin 2t, you can see this is y, this minus is written at the top, into, similarly this is x. Now here x is e raised to cos 2t. Then if we want to find out this cos 2t, this e can be removed by taking this log. Means if you want to remove e from one side, then other side will come log. So means cos 2t is same as log x. Similarly sin 2t is same as log y. Here is the written rule, y equal to e raised to x, then this x is equal to log y. Reverse order also possible. One side e we want to remove, other side will come log. Similarly, one side log you want to remove, other side will come e raised to. That's the rule. Now higher order derivative means differentiate again and again differentiate. If y is equal to f of x, then dy by dx equal to d f dash x. This is one time differentiated. So this is called the first order derivative of y with respect to x. First order derivative of y with respect to x. Now here second order derivative of y with respect to x denoted by d square y by dx square. You see d having square and x is having square. Y does not have a square, so means y is alone, y derivative is there. So d square y by dx square is also same as second f double dash x. Yeah, it is also denoted y2 and y dash, y double dash, y2, y double dash. Now, example, y is equal to cos x, dy by dx equal to minus sin x. So, d square y by dx square will come, again differentiate this is minus cos x. Another example, y is equal to this, dy by dx, chain rule applied. Second derivative, again apply chain rule, you may see that minus m square is a constant, minus m square into y. So, very carefully observe this question, it's a parametric function is given. So I can find out all these observations, these all terms you can find out, dy by d theta, y with respect to theta. Now then again differentiate in d square y by d theta square. Here both are differentiate with respect to theta. So we get minus a cos theta. Similarly dx by d theta, a into 1 minus cos theta, again differentiate in d square by d theta square. So here also both are differentiated with respect to theta. But when if you are dividing, you will not get a d square by dx square. This and this division are entirely different. This is d square by dx square. Here d square y by d square x. So both are different. So never you will get a d square y by dx square by directly dividing the second derivative. So whenever you want d square y by dx square, first you will find out dy by dx. So y derivative upon x derivative divided, simplify 2 sin theta by 2 cos theta by 2 sin theta is same as and 1 minus cos theta 2 sin square theta by 2 minus cot theta by 2. Now second derivative minus cot derivative is minus again, so cos square theta by 2, here theta is the variable and here x is the variable. So the theta by 2 derivative is 1 by 2 into d theta by dx, as y derivative is dy by dx, so theta derivative is d theta by dx, that is cos square theta by 2 into this 1 by 2 into d theta by dx is the reciprocal of dx by d theta, that is written there, its reciprocal is written there. Next another question is y is equal to sin inverse x upon root of 1 minus x square. Now we need to show this part, so here direct if you are applying quotient to be applied. So to avoid quotient rule, first I cross multiply and I apply product rule. Product rule is more simple than a quotient rule. So applying product rule, root of 1 minus x square into y derivative y1 means dy by dx plus y into root derivative is 1 upon root 2 root of 1 minus x square into 1 minus x square derivative minus 2x is equal to sin inverse derivative is 1 minus root of 1 minus x square. Cross multiplying, this root get cancelled, 1 minus x square into y1. This root also get cancelled, so it will come minus xy is equal to 1. This is one time differentiated. Again differentiating, we are apply product rule. Here also apply product rule. 1 minus x square into y1 derivative y2 plus y1 into 1 minus x square derivative minus 2x minus of here also product rule x into y derivative y1 plus y into x derivative 1, that is 1 derivative 0. Simplifying, opening this bracket, you will get 1 minus x square into y2 minus 3xy1 minus y equal to 0. Similarly, this is given, we want to prove this part. So similarly, y is equal to sine of log x, y1 chain rule applied, sine derivative cos and log x derivative 1 by x. Here again I cross multiplied. Before going for second derivative, I will get xy1 equal to cos of log x. One time differentiation, product rule, x into y1 derivative y2 plus y1 into x derivative 1 is equal to chain rule minus cos derivative is minus sine, log derivative is 1 by x. Again cross multiply, you will get x square y2 plus xy1 is equal to minus y, because sine log x is same as y. So I brought this y to the left hand side. You can prove it like that. There's another question, y is equal to tan inverse x, find d square by dx square in y. If you are directly differentiating, you will get only in terms of x. We need the result in terms of y. So I brought this tan to the left hand side. So x is equal to tan y. So dx by dy, first I find out d 6 square y. Now take the reciprocal dy by dx, then only I can find out d square by dx. So first I find out dy by dx. So its reciprocal is cos y. Now you differentiate minus first 2 cos y into cos y derivative minus sin y. So that is why minus 2 cos y sin y into here y and x are the variables. So y derivative is dy by dx. So that is minus, this is sin 2y into dy by dx is alternative and that is into cos square y. So that's the answer in terms of y.